Hello and welcome. So in this video, we're going to talk about overall heat transfer coefficient. So overall heat transfer coefficient is usually seen or used in the analysis of heat exchangers because of many thermal resistances in the heat exchanger. They usually denote all of it in terms of overall heat transfer coefficient. But in this video, we're going to talk where or how it is derived or how overall heat transfer is being derived. So consider the plane wall shown. This wall is exposed to a hot fluid A on one side and a cooler fluid B on the other side. So you already know that if we have a fluid, hot and cold fluid in the sides of our wall is considered as heat convection. Okay, so the heat transfer is expressed by the this equation. Okay, wherein the first term H1A times TA minus T1 is in this section, which is the thermal or the heat convection for fluid A. Then on the other side, in this area, we have this one H2 times A times the quantity T2 minus Tb. So as you can see, Ta minus T1, which is A is a hot fluid, then T1, which is here in the surface of the wall, and then T2 minus Tb is here in this side of the wall, the surface of the wall, and Tb, the temperature of the fluid. Already know how these equations has been derived, okay, from the thermal or from the second mode of heat transfer, which is thermal or heat convection. And then in the middle, we all know that this heat transfer is due to convection. That's why this equation is our conduction equation, wherein T1 is in this side, which is hotter or hot than T2. And then it is equal, Q is equal to this one, the convection in fluid A, conduction of the wall, and the convection for fluid B, because we assume that Q is constant all the way down from fluid A to fluid B. And then when we will write the thermal circuit of this plane wall, we will be writing this whole term, okay, wherein our first thermal resistance is this one in fluid A, second one is for the conduction, and the third one is for fluid B. So you can see 1 over H1, of course H1, this one, in times area. Next is delta x or the thickness. This is the delta x or the thickness of the wall. And then next, of course, 1 over H2 times area for the fluid B. Okay, well, we all know how these are being derived. So next, we usually write heat flow in this manner. Q is equals to delta T over the total thermal resistance. And in this case, the total thermal resistance is the summation of the three thermal resistances in this wall. So the total thermal resistance would be 1 over H1, or is written on this side. Here you can see this one. This one. There you go. Wherein the denominator is the total thermal resistance. So the overall heat transfer by combined conduction and convection is frequently expressed in terms of overall heat transfer coefficient. So meaning, lahat ng mga resistance ng conduction convection is pwede mong express or frequently expressed daw in terms of overall heat transfer coefficient. Therefore, yung equation natin for heat transfer is magiging ganito po. Q equals U times A times the delta T overall. Okay? Wherein U yung tinatawag natin na overall heat transfer coefficient. So, paano nga ba nangyari or paano naging ganyan yung ating heat transfer equation na lagi sinasabi natin in general, dahil ang ginagawa natin lagi is itong nasa taas na delta T, tapos summation lahat ng thermal resistances. So, sabi dito is ang U daw is 1 over yung ito po. So, take note, huwag mali dito. Okay, 1 over 1 plus, 1 over H1 plus delta X over K, and then 1 over H2. So, mapapansin nyo, ang akalain nyo, ang U daw, baka sabihin nyo madalas is ang U is 1 over R TH, which is mali po. Dahil ang U po is 1 over R value. Hindi po siya directly reciprocal lang ng total thermal resistances na RTH. Okay? So, ang R ay ang overall heat transfer coefficient is 1 over R value. And then, ito, may take note tayo dito. Dito natin makikita na ang R value is total thermal resistances times area. Yan po. Para hindi po malito. Wherein R value, meron tayong unit na meter squared times degree Celsius over watts, or feet squared degree Fahrenheit R per BTU. So, if we will derive kung paano nakuha itong equation natin, take note pala itong equation na denote natin as 1. Madalas natin makikita to sa heat exchanger analysis. So, i-memorize na po natin yan. So, kung makita natin, kung substitute natin yung U dito sa ating equation, iba lang natin na ang Q is equals to delta T over thermal resistance or total thermal resistance. Yan yung unang alam natin na equation. Pero sabi, ang Q daw is pwede rin pag overall heat transfer coefficient ang given, UA delta T. Yan ang magiging equation daw natin. So, paano ba naging ganyan yung equation natin? Yan nga, yung thermal resistance natin. Kung isusulat natin yung thermal resistance ng tatlong nasa itaas na thermal resistances is ito po sila. Ito po. Pero makikita natin, pag U na ang sinulat, natatanggal po yung area. Yung area dito. Dapat may area dyan, may area dapat dito, area, and area. So, meaning finactor out nung U, yung area. Kaya nga yung R value is merong area din dito. That's why merong area po na nakasulat dapat dito sa ating equation dahil masabi rin natin na ang U is 1 over R value times A delta T or pwede rin sabihin ulit natin na ang R value nga is 1 over R thermal resistance times A, which is galing po dito, times A ulit, delta T. And, pag kinancel natin yung A, babalik tayo sa dati equation natin na delta T over R thermal resistance. So, in short, same pa rin po. Ito, kaso nga lang, itong U pag medyo madami, given na madalas to sa problem. Okay? So, next. Paano naman pag mga cylinders na po ang pinag-uusapan? So, now, let's consider in the case of cylinder. So, we all know, na-review na natin from the last video, na kapag cylinder na ang pinag-uusapan or sa problem, ang area natin for the thermal resistance sa convection is dapat memorize natin 2 pi KL or sorry, hindi pala RL. And then for sphere, kung sakaling sphere yung problem, is 4 pi r squared. And then thermal resistance natin, pag conduction, pinag-uusapan, of course, alam na natin yan, which is ln R, R2 or R outside, yung bigger radius over R inside, over 2 pi KL. Ayan. Medyo magkamukha po itong 2 pi KL saka 2 pi RL. Kaya wag natin pagbaliktarin. So, for a hollow cylinder exposed to a convection on its inner and outer surface, TA and TB are the two fluid temperatures. Note that the area for convection is not the same for both fluids. Ayan. I-note natin yan. Take note. Hindi daw same yung area for convection. So, ibig sabihin, yung area na to, yung formula na area na to is hindi same for both fluid. for temperature A and temperature B. So, consider natin drawing. Ayan, meron tayong cylinder wherein fluid B dumadaan sa labas nung bali ito yung tinutukoy na natin ng cylinder. Okay, ito po. Ito pong sa loob na to. Bali kung drawing natin yung cross section niya. Of course, this is R inside. Tapos meron tayong R outside. And then dito yung fluid A wherein meron tayong HI inside saka temperature A. Tapos dito yung temperature B. Tapos convection coefficient na HO4 outside. Okay. So we already know if we will draw the thermal circuit for this scenario. Makikita natin dito na meron tayong tatlong thermal resistance. Ito yung pangatlo, may given na case. So, unang thermal resistance, of course, convection sa inside, convection sa outside, tapos conduction dun sa gitna. Ito yung mga magiging thermal resistance natin. And then, always, pag nagsosolve tayo, Q is equals to delta T over the total thermal resistance, which in turns, ganito yung magiging itsura pag sinubstitute mo siya ng buo. Okay. So, ayun, same concept lang. Masulat mo pa rin itong formula na to, kahit na cylinder siya in terms of overall heat transfer coefficient. Pero take note, ano na yung note natin kanina? Yung area daw ng fluid A and fluid B, ayan, for convection is not the same for both fluids. So, nakikita natin dito na ang ating Q for it is base. Ang Q natin is pwedeng mag-base either inside or outside area of the tube. So, makikita natin dito yung UI saka UO. So, pagdating sa cylinder, it depends kung anong tinatanong. Pwedeng ang Q is based on inside ko. So, kung inside, UI ang gagamitin natin, of course. Tapos, area I times delta T. So, pag base in outside, of course, UO kasi outside. And then, delta O or area O pala times delta T. Ayan. So, yan yung magiging mga formula natin pag base siya sa tubes or cylinders. So, paano nga ba na-derive yung IU saka IO? Na-derive yan using this one. Alam naman natin, di ba? Galing nga pa rin siya dito. Saan laging ginagamit natin. So, ito, kunin natin to para ma-derive natin yung IU saka IO. Okay. So, ano ba ang U natin ulit? Ang U natin is equals to 1 over R value. Wherein yung R value daw, ulit, ano yun? R thermal or total resistance times area. Ano yung total resistance natin pagdating sa ganitong scenario ng cylinders? Ito po. Okay, rewrite lang natin. Magiging 1 over H I A plus ln RO over RI over 2 pi KL plus 1 over HO AO. Take note pala dito, no? Alam naman na natin to pero review lang. Kita natin, no? HI of course kasi sa inside fluid, and then AI kasi ang gagamitin mong area dyan is, sulat na lang natin dito. Ang area mo dyan is 2 pi RL, wherein yung I na gagamitin mo is of course inside. Kaya AI rin yung nakalagay inside. Pagdating naman dito, AO, ang area natin syempre magiging 2 pi RO, yung outside radius times L. Kaya O, AO, area O yung ginamit O natin. Okay? Huwag po tayo malilito doon. So ngayon, ito, ituloy natin. Multiply pa natin siya ng area. So ngayon, dito na magbe-base kung if yung gusto mong U is based on inside or based on outside. So unahin natin yung based on inside. So sasabihin natin U ay yung hinahanap natin dito. So UI ang hinahanap natin. So therefore, kailangan natin i-multiply ng inside area din. Okay? Gawin natin red para makita natin na multiply natin sa inside area. So if ka-cancel out natin yung inside area, kita natin na magka-cancel out dito. Dito, walang magka-cancel out. Dito rin sa third term, wala rin. So, magiging final equation natin pag overall heat transfer based on the inside area is 1 over H I inside plus A I inside area times RO over RI divided by 2 pi KL plus AI over HO AO. So, yan na po. Yan na po yung overall heat transfer coefficient natin based on the inside area or inside radius. Pwede rin sabihin ganon, inside radius. So, pagdating naman sa solve natin yung overall heat transfer coefficient based on the outside, sabihin natin gusto natin is based on the outside. Of course, ganon ulit ang process. Galing siya sa R value. So, alam na natin, R value is R thermal resistance total times area, and of course based on outside tayo, so outside din yung area natin. So substitute natin yung total thermal resistance, yung 1 over H I A I plus ln radius outside over radius inside over 2 pi KL plus 1 over HO AO. multiplied by 1 po yung denominator, ay numerator, times area outside. So our final overall heat transfer coefficient based on outside is 1 over A O H I plus ln RO Ri over 2 pi KL plus 1 over HO. So there we go. And yan po yung final derivation ng ating overall heat transfer coefficient based on the outside.